All right, everyone, welcome to another episode of the Base-12 Book Club, where I'm introducing my recent book called Understanding Base-12 Math, How to Draw the Perfect Circle Using Dozenal Geometry. So in this episode, we're going to be looking at the Base-12 dodecagon, which I'm going over in Chapter 3, where you see all the various dimensions and lengths and things of this new geometric pattern. And what I'm going to do in this video is actually introduce you to some of the drawings that I did that I didn't include in the book. And in some ways I wish I had, but you can only do so much before it just has to be published. So what I'm doing here is I'm going to connect the dots and form two circles, because we can see already that the dodecagon is a dodecagon. It's an irregular dodecagon in the sense that all of the points that define its sides are not equidistant from the center. All the sides are the same length, but the points which define those sides, those lengths, aren't all equidistant from the center. So we can draw two rings or two circles and form one ring when we connect those dots in this form. So you can see there we have two circles. Those circles are defined by the points which define the shape of the dodecagon, and we formed a ring, and that ring is going to have some area. So my question for you is, what is the area of that ring? And so we know that this is the innermost ring of the pattern, and that the pattern is a repeating pattern. So every consecutive ring after this is always going to be formed, or the area of that ring is always going to be in units of this initial first ring of the diagram, or the very first ring formed by the dodecagon, the smallest version of the dodecagon. So I think you have all the geometric knowledge. I'll show you this picture here, where I've drawn a line that defines the 1 in Base-12, and the triangle, the dimensions of this triangle are in the book. And I'll give you a hint that the some equations in Base-12 look the same as they are in Base-10, even though they're a little bit different. And maybe you even want to figure out that area from a Base-10 point of view as well as Base-12, and then just see what the difference is. So I'm going to leave you with some homework. I'm not going to give you the answer to the area of that circle. I got to go off to work right now, so I just thought I'd squeeze in this video, and I'll see you in the next one. So there's something to think about. What's the area of this ring? And also, is it possible to build a physical circle using the dimensions or the definition that's given to us by mathematicians, that a circle is built with infinite dimensionless points? Can you build a circle with infinite dimensionless points using, what I'm trying to say is, what's the difference? This is an example of the difference between applied math and pure math. Can you build things in pure math with the definitions that we currently have? Anyway, that's something to think about, and I'll see you in the next video. Thanks for watching.